Okay, I'm sorry, I didn't finish that problem. 7-4, let's talk about that one, ready? The way we get this conversion factor is we use this really cool feature of the periodic table. The periodic table, if you look at it, in fact, I'm gonna have you use this one and tell me the answers for this. Here, hold on, back cover. On the back cover, you have this periodic table. On the very bottom, you have those numbers. That is the atomic mass weight, the molar mass of each element. And it's basically saying if we gathered together 1 mole of hydrogen, it would weigh 1 gram. I think it's grams. Yeah, grams. So if we gathered 1 mole, all right, so if we gathered 1 mole of hydrogen, it would be 1 gram of hydrogen. Cool? If we gathered 1 mole of oxygen, how many grams of hydrogen, or how many grams would it be? Come on, man, know your periodic table.
15 or 16?
16. Yeah. 16 grams of oxygen. So, how do we figure out the answer to this? It's really simple. All you do is this. How many moles of hydrogen are we dealing with in 1 mole of hydrogen peroxide? 2, right?
Yes.
How many moles of oxygen are we dealing with in 1 mole of hydrogen peroxide?
4.
Oxygen.
Oh, 2.
2. So what we should do is we should take this number, multiply it by 2, take this number, multiply it by 2. So this becomes 2 grams of hydrogen, and this becomes 32 grams of oxygen. Cool? And we'll add them together. And so we get 34 grams of H2O2. So that's your answer. 1 mole of H2O2 is equal to 34 grams of H2O2. That's how you convert that. And you're going to have to use this trick. You're going to have to use the periodic table a lot. In fact, so much so that I would almost recommend that you memorize some of these molar masses. A really common one is going to be oxygen. A really common one is going to be nitrogen and carbon, and so you're gonna have these ones memorized after a while. Hopefully, if you do a lot of these problems. Go back to. Apparently, I have to record these videos real quick because we don't have a whole lot of time. All right, here we go. All right, here's a good one. Let's just try this one together. Ready? Ammonium carbonate. So the formula for ammonia is NH3. Carbonate, I think, is C2O4. Is it C2O4? C2O3? Oh, CO3. All right. NH3, CO3, and I think there's a 2 here. Okay. Ammonium carbonate. What is the molar mass of that? Okay, well, here's how you do it. Ready? Flip to the back of the book. In fact, let's add our bookmark in there. All right, flip to the back of the book. All right, give me the molar mass of nitrogen.
14.
What's the molar mass of hydrogen?
1.
What's the molar mass of carbon?
12.
What's the molar mass of oxygen?
16.
All right, go back to the problem. Ammonium carbonate. How many nitrogens are in this formula?
1.
No,
Oh. 2?
there are 2. Because this 2 over here, it's almost, I mean, it's almost mathematical. Like, this 2 over here is applying to this inside the parentheses. So you have 2 nitrogens we're doing. So we need to multiply this number by 2. How many grams, or how many things of hydrogen are we dealing with?
8.
Why 8?
Oh, yeah, it says 4.
Oh, I'm sorry. This is NH4. Okay, 8. So we multiply this by 8. Without looking at the answer, how many things of carbon are we dealing with?
1.
Just 1.
1.
How many things of oxygen do we have here? Without looking at the book.
3.
3. Alright. Multiply 2 times 14, you get 28. Multiply 1 times 8, you get 8. This is 12. 16 times 3. What is that? That's 48. Add them all up, you get 96. So that's the molar mass of ammonium carbonate. Does that make sense?
Yes.
And then what we're going to do later on is we're going to say, hey, I have 5 moles of ammonium carbonate. How many grams does that weigh? And so you can say, well, if you have 5 moles of that stuff, you can multiply that by 1 mole of that stuff I know is 96 grams. How do you know that? Well, because I was able to calculate out the molar mass of that stuff. And then you say, well, 5 times 96 is whatever, whatever. Does that make sense? Was that 480? 480.
Sure.
I don't know if it's 480, to be honest with you. I just made it up. I think it is, actually. Yeah. All right, anyway. All right, cool.